8.6 is also on angles, and it is also part of the lesson with 8.5 from the book. And what I want you to look at today is we're going to look at some more angles, but we're going to look at some relationships between those angles. The first one being, what do you notice about X and Y? Do you see that they form a line, right? They make a straight angle. X and Y do. So they make a straight angle. This is, by the way, the abbreviation for angle. I just write an angle. What about Y and Z? Oh, also a straight angle. What about X and Z? Okay, not a straight angle, do they? Do you know that we can find every one of these angles without using a protractor? So let's start. How do you find X? Well, if doesn't that make a straight angle with 108? Well, that's 180, isn't it? So 180 subtracted 108 is 72. Well, what does that make Y then? Right, 108. What does that make Z then? 72. Interesting. Now, these other two angles are going to be difficult for you to find, but I bet you can figure it out. Okay? I think you can figure it out. What do you know about Z and W? Well, what kind of triangle is this? Even though we're going to talk about this later in the year, what kind of triangle is that? Do you think those two sides are equal? You're right, they are. So what do you know about angles Z and W? They're also equal. So 72 plus 72 is 144. If you subtract 180 or 144 from 180, because it's a triangle, there's 180 degrees in a triangle, you have 36 degrees. Now these two might be out of our range of thought at this time, and that's okay. Just want to get you thinking. Okay, how about this? If we take a square and we draw in the diagonals, what do you notice about A and B? Well, what do you think? What do they make? That's a 90-degree angle, right? Because it's a right angle, it's a square. How about C and D? Oh my gosh. It's a straight angle. What about C and E? What do you think about those? Do you think those are also right angles? I believe they are. Now it says find the values of the indicated measures not using a protractor. Okay, well how do you find, what's C? Obviously 90, because it's a straight angle with this one. It's 90 degrees. What about D? Well, that's a straight angle with C. What about E? Well, that's a straight angle with D. So just use some logic and you can decipher all that. Now, our next topic, I can't emphasize to you enough that we need to make sure and have these in our notes because this is really, really important. Complementary angles. Two angles whose measures have a sum of 90. So they do not have to be side by side like these two are. They do not have to look like that. They can look like these. Any two angles that add up to 90. Supplementary are any two that add up to 180. Okay? Now the third concept here we call adjacent angles. Now there's some things about adjacent angles that we want to understand. We have a couple of things in common. They have to have a common vertex. They have to have a common side. The other thing that they can't have is they share no common interior points. So they share common vertex, share common side, but they don't have any interior points in common. So you can see that if I put a bunch of points in 5, they're also not in 6 and vice versa. Now 7 and 8 are not adjacent or non-adjacent because they don't share a common vertex or a side. So they can't be adjacent. So if we go back up here, These are adjacent. These are not. These are adjacent. These are not. Okay? So in the figure, name a pair of complementary angles. Okay, has to add up to 90. 53 plus 37 equal 90. So our complementary angles would be angle RST and angle CAB. How about our supplements? 127 and 53, so that'd be angle CAD and angle RST again. What about a pair of adjacent angles? Right, so it's got to be BAC and DAC, or CAD, however you want to say it, but these are adjacent. They share a common vertex, they share a common side right here, the side's ray AC, but they don't have any points in common on the interior. Okay, angle 1 is a complement of angle 2, which means what? They add up to 90. So if angle 1's 62, what's angle 2? 90 minus 62, correct, 28 degrees. 3 and 4 are supplements, so they add up to 180. If angle 4 is 47, what is angle 3? 133. Okay, using that figure, name a pair of complements, supplements, and adjacent. Well, let's see. A pair of complements, remember that's 90. Complementary angles would be 41 plus 49, right? Angle FGK and angle GKL. That would be the complements. Supplementary angles would be 131 and 49. So HGK and angle GKL. And then adjacent angles, only one choice here, angle FGK and angle KGH. Then the question asks, is angle KGH, that's this, and LKG adjacent angles? Right, no, they don't share a common vertex, do they? Are angle FGK, this one, and FGH adjacent angles? Yes, they share a common side, right here. They share a common vertex, but they don't have any common interior points. So yes, these are adjacent. All right, how about this? Angle 1 is a complement of angle 2. That means they add up to 90. Angle 2 is 5. What's angle 1? 85 degrees, isn't it? 90 minus 5. 3 is a supplement of 4, which means they add up to 180. Well, if 3 is 148, what's 4? Got to subtract, don't you? 32. Again, if this is too fast, it's not meant for you to take this in one chunk. You should pause it and think about it, solve it for yourself, and then look, oh yeah, I got the same answer. Okay, when viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. Find the measure of angle BCE and the measure of angle ECD. So we want to know this angle right here, these two angles. So 4x plus 8 plus x plus 2 forms a line, right? Because it's supplementary, equals 180. So again, we're going to combine like terms. Then we're going to subtract. And we get 170 divided by 5. So x is 34. Now that's not the answer, is it? We got to plug 34 in there. So ECD is 36. So I believe this should be 144. Check the math here. 34 times 4. 34 times 4 is 136. And if you add 8, you get 144. Okay. Angle LMN and angle PQR are complementary angles. Find the measures of the angles when 4x minus 2 is LMN and PQR is 9x plus 1. Well, what does complementary mean? It means they add up to 90. So there you go. Solve it. 13x minus 1 equals 90. Combine like terms. Add 1. 13x equals 91. We're going to divide by 13. And that is 7. Now we haven't found the angles, have we? So we got to plug 7 in there. 4 times 7 is 28. 28 minus 2 is 26 degrees. Plug 7 in there, you get 63 degrees plus 1, which is 64. Now do those two add up to 90? Yes, they do. All right, now the last subject then are linear pairs and vertical pairs. Okay, very important that you master these two concepts. All right, a linear pair, guys, simply forms a line. They simply form a line, two angles that form a line. Vertical angles are made by drawing an X and looking at the opposite pairs. So 3 and 6 are vertical, 4 and 5 are vertical. A linear pair, make a line. So get those concepts separated in your mind. So now identify all the linear pairs and all the vertical pairs. There's not as many as you think. Okay, what are the linear pairs? Well, 1 and 4 make a line. Do 1 and 2? Nope. Well, 1, 2, and 3 do, but this is called a linear pair. Pair means 2. So there aren't two angles here that make a line. So 1 and 4 and 4 and 5, I believe, are it. Because 5 and 3 doesn't work, so on. So that won't work. So we can't do anything with that. Okay, now what about vertical angles? Well, vertical, they have to form an X, okay, and then be opposite. Well, 2 and 4 don't form an X, do they? Because we don't have that in there. So 2 doesn't have a vertical angle. Does 3? No, I don't think so either. Does 5? Yes. 1 and 5. And that is it. That's all the examples in that picture. Okay, two angles form a linear pair. Okay, let's do that. Draw a line. Two angles form a linear pair. Angle 1 and angle 2. That makes a line. There you go. The measure of one angle is 5 times the measure of the other angle. So let's say this angle is x. How big is angle 2 then? 5x. It's 5 times bigger. Find the measure of the angles. Well, okay. What do these two add up to? 180. They're supplementary, aren't they? So 6x equals 180. Hey, this is 30. This is 150. 5 times 30 is 150, so that's 5 times bigger. Got it. All right. Do any of the numbered angles in the figure form a linear pair? If you said no, you're right, because you have to have two angles form a line, and we don't have that. How about vertical? A lot, right? We have 1 and 4, 2 and 5, 3 and 6. Those are all vertical. All right, 7, the measure of an angle is twice the measure of its complement. So if we let an angle be x, What is the complement of the angle? Well, it has to add up to 90, right? So the complement is 90 minus that angle, x. So if we just read this, the measure of an angle, x, is twice the measure of the complement. So the measure of an angle is twice as big, is means equal, twice as big as the complement. There you go. The measure of an angle, x, equals twice as much as the complement. So how do we get rid of parentheses? We distribute, right? So when we do that, we get 180 minus 2x. We add 2x. 3x equals 180. So x is 60, isn't it? So the angles are 60 and 30. Do they add up to 90? Yes. Is one twice the other? Yes, it is. Okay, two angles form a linear pair. Well, that'd be 180, wouldn't it? The measure of one angle is 1.5 times the measure of the angle, the other. So it stands to reason then that it's simply x plus 1.5x. So that's 2.5x divided by 2.5. Not sure what that is. 72. So one angle is 72. The other would be 180 minus that, which is 108, because it has to add up to 180. All right, now, this is a summary in your book that I really, really, really would like you to look over and make sure you get all these terms, okay? And make sure on your Zooms or in person you ask as many